When we say the axis of the heart, we're talking about the average direction of the electrical activity throughout the ventricle. Basically, what direction the electrical uh, activity, or if you want to call it electrical current, what direction does it flow in? What general direction? Remember when we said that the the pacemaker of the heart is the sinoatrial node or the sinus node, and the sinus node is located at the junction of the superior vena cava and the right atrium. It's a very tiny, uh, specialized conduction tissue, and we call that the sinoatrial node. Now, that's a pacemaker of the heart. That's where all the electrical activity originates or starts. So, if in saying that, and of course, you know that the sinus the sinus atrial node is going to be on the more on the right side. Let me see if I can draw it. It's going to be more on the right side of the heart. I'm going to just highlight it. It's not this big, of course, you know that. But if it's right here, and it's going the electrical activity is gonna be is originating from here, and it's going to travel through the atrium and then down the ventricle. Then this is the general direction, right? This is the general direction that the electrical impulse is traveling in. So it traveling, if you could extend it, you could say it's traveling from like the right shoulder to the left breast. Okay, that's a general direction that the electrical activity travels. And that's basically what we call the axis of the heart. The average direction of the electrical activity through ventricular activation. Okay, what is the general direction that the electrical impulse travels? And that it's very important, and that of course that's why that's why we study it, because it's very important. If the axis is not in the right direction, then that can tell you that there's something wrong with the heart. Okay, so if the electrical activity is not in the proper direction, then that will tell you that there is something wrong with the heart. Okay, so now you know what's the definition of the axis is. Now you see a series of numbers here. You just have to know them. Okay, it's not difficult. If you really wanna impress the medical people around you, and if you just want to learn this thing, then just walk around with a cheat sheet. You can go online, download one, walk around with it, and then over over time you'll fully uh you'll remember all of this. All right, so it looks very busy, but it's relatively simple. Okay. um Okay, so we this is a circle, and of course, when you have a horizontal, it's either 0 or 180. Okay, so lead one subtends an angle of 0. Lead two subtends an angle. Positive lead two is plus 60. Positive lead two is down here. An important point is all the degrees down here is positive and everything up here is negative. So that's an important point. But the different leads have different angles, and this is what um, this diagram is important of showing the different angles that the various leads subtends. So lead one, positive lead one is over here, and it subtends an angle of 0 degrees. Negative lead one is on the opposite side, and that's plus or minus 180. Lead two, okay, so you have lead one, lead two, these are limb leads. Lead positive lead two, remember what we said. All the numbers down here, the degrees down here is positive. Lead two, positive lead two is 60 degrees. If you want negative lead two, you have to go in the opposite direction, and that's going to be minus 120. AVF is right here, and positive AVF has an angle of 90 degrees. So negative AVF, you have to go in the opposite direction, is minus 90. Lead 3 subtends an angle of 120, positive 120. Negative lead 3, you have to go in the opposite direction. It's minus 60. So these two handles are complementary. The sum total of them is going to be 180 degrees. That is why if this is 60, this is 120. If this is 90, it's going to be 90. The negative AVF is going to be 90 because the sum total is going to be 180. So positively 3, 120 degrees, negatively 3, minus 60. Because remember what we said, all the stuff up here is negative, these are positive. Okay, so AVL is minus 30 because it's in this quadrant. AVL is minus 30. Okay, positive AVL is in the opposite direction. 30 and 150 is 180. So negative AVL is plus 150. Okay, AVR, positive AVR is minus 150. So negative AVR is plus 130. If you guys want to understand it fully, okay, then you will have to walk around with a cheat sheet. As I say, download it, walk around with it. You're not going to need it so much in your echo career, but if you want to fully understand it and impress those around you, then you can do that. And you know you need to know this in order to determine the axis. Okay, you need to know this diagram fully in order to determine axis, and let me show you why. All right, so again, remember what I said about the axis. So the axis is the average direction that the electrical activity travels through the heart. And you just have to know, you know, if all you leave here tonight understanding the general direction that the electrical activity travels, that's enough. Okay? If the axis is abnormal, it tells you something is wrong with the heart. So the normal axis is between 0 and 90. So again, if we go back to, so 0 and 90 is right here. So the normal axis should be within this quadrant, should be in this quadrant, 0 to plus 90. So the normal axis should be in this quadrant. Again, we said the impulse is coming from the SA node coming in this direction. So it can be anywhere from 0 to plus 90. That's a normal axis, okay? When we say right axis, then the axis is moving more to the right side. And let's just look at this. So when we say right axis, it's in the right quadrant. So this is the right quadrant, right? So this is when if you find the axis somewhere between plus 90 and 180, then it's in the right axis. It's right axis. This is the normal axis between 0 and 90. And similarly, left axis is, we say, is between 0 and minus 90. So left axis is in the left upper quadrant. Okay, right axis is in the right lower quadrant. The normal axis is in this quadrant from 0 to plus 90. So again, if you just have broad understanding, it's fine. Okay, but we can determine the axis fairly accurately. And again, as we said, there's some heart disease that will cause variation in the axis. There's going to be some heart disease that will cause variation in the axis. If you want to determine the axis of the heart, there's a few things you need to know. You need to know the limb leads. And as we pointed out before, you have three regular limb leads, lead 1, lead 2, and lead 3. And then you have three augmented leads, that is AVR, AVL, and AVF. So these are the limb leads. These are limb leads. You have the regular limb leads and then the augmented limb leads. When you're going to find the axis of the heart, first you look in the limb leads, 6 of them, and you want to find the lead that is the most isoelectric. The lead that is most isoelectric. Remember, iso means same. So what we're saying is it's going to have the same amount of positivity and negativity. That is, the portion above the baseline is going to be almost equal to the portion below the baseline. That is what we call isoelectric. Then to find to find the axis now, you'll find the lead that's perpendicular to the most isoelectric lead. So it's best to demonstrate it than talk about it. So let's do the demonstration. So these are all the only stuff, the only things you need to determine the axis. You need to look at all your limb leads. You need to find the most isoelectric, and then you find the lead that's perpendicular to it, and then that's the axis. Okay? All right, so let's look at this 12 ECG. All right, so you guys should be looking at 12-lead ECG because we did the basic stuff, so you should have some understanding of the 12-lead ECG. Remember, you put 10 electrodes on and you get 12 leads. So this is lead 1, this is lead 2, this is lead 3, this is AVR, AVL, and AVF. So these are the limb leads. So we're going to look at our limb leads, and we want to find the most isoelectric lead from the limb leads. Again, when we say isoelectric, we mean the top portion is almost as big as the bottom portion. So the portion going up is almost equal to the portion going down. Okay? The portion going up is almost equal to the portion going down. So when you look at your limb leads, so these are your limb leads, regular limb leads, augmented limb leads. Lead 2 is the most isoelectric, right? Because you can see the positivity, the portion going up, that's almost equal to the portion going down. So lead 2 of all your limb leads is the most isoelectric. The lead that is perpendicular to lead 2, all right, let's go back. Okay, you have your cheat sheet. So this is lead 2. When we say perpendicular, we mean 90 degrees. Perpendicular means 90 degrees. So this is lead 2. The lead that 90 degrees to that is AVL. You can see that this angle is 90 degrees. So AVL is perpendicular to lead 2. All right, so if you had your cheat sheet, you don't have to go back and forth. So two, lead 2 is the most isoelectric. Lead 2 is the most isoelectric. Perpendicular to lead 2 is AVL. AVL, let's go back to our cheat sheet. AVL subtends an angle of minus 30. Okay? AVL subtends an angle of minus 30. So the axis is minus 30. I think that's relatively simple. So again, look at your limb leads, okay? Look at your limb leads. Then you determine which of your limb leads is the most isoelectric, okay? So isoelectricity, the positive is gonna be almost equal to the negative. The most isoelectric is the one that's closest to isoelectricity is uh, is lead 2. Perpendicular to lead 2 from the cheat sheet when we went back is AVL. Again, AVL subtends an angle of minus 30. So the axis here is minus 30. And that's not really difficult, right? All right. Let's look at another one. So again, our 12 lead ECG, we put 10 electrodes on, we get 12 leads. These are regular limb leads. These are or augmented limb leads. So when we look at our limb leads, the most isoelectric, that is the positive almost equal to negative, AVL. Okay, the most isoelectric is AVL. Perpendicular to AVL, so go back to your cheat sheet. So AVL is, this is AVL. Perpendicular to AVL, when we say perpendicularity, we mean 90 degrees. So lead 2 is perpendicular to AVL. Lead 2 was positive, so positive lead 2 is 60 degrees, subtends an angle of 60 degrees. So, so this is supposed to be 60 degrees, okay? So this is 60 degrees. So again, you look in your limb leads, the most isoelectric, you're gonna, that means the upper portion should equal to the lower portion. This is most isoelectric, AVL. Perpendicular to AVL, lead 2. Lead 2 is positive, okay? Because it goes above the baseline. Positive lead 2 subtends an angle of 60 degrees. So the axis here is 60 degrees. Remember, the normal axis is between 0 and 90. The electrical impulse, if it travels in that quadrant, it's normal. All right? Let's look at another one. All right. So again, we look at the limb leads. We look at the limb leads. The most isoelectric is lead 1, right? You can see that the positive is almost equal to the negative. So when you look at all your limb leads, lead 1 is the most isoelectric. Then you're going to find the lead that's perpendicular to lead 1. You go back to your cheat sheet. So lead 1 is right here. This is lead 1. Perpendicular to lead 1, that's 90 degrees. That's AVF, right? AVF. So AVF is perpendicular to lead 1 because lead 1 is 0. Perpendicular to lead 1 is AVF. Positive AVF is 90. Negative AVF is minus 90. So let's see what our axis turns out to be. So again, the most isoelectric is lead 1. Perpendicular to lead 1 is AVF. AVF is positive because it's above the baseline. So therefore, the axis is 90 degrees. So if you had your cheat sheet, you just look on it and quickly you can determine the axis. All right, let's do another one. All right, so let's look at this. Look at our limb leads. Okay, the most isoelectric in our limb leads. So when we look at all of them, say negative equal to positive. Well, so probably lead 3. If you want to say lead 3, if you think lead 3 is the most isoelectric, then which lead is perpendicular to lead 3? All right, let's go back. So you have your cheat sheet and you look at lead 3. So lead 3 is right here. Okay, lead 3 is right here. Perpendicular to lead 3, that's 90 degrees, is AVR. So this angle is 90 degrees. This angle is 90 degrees. So is AVR is is perpendicular to lead 3. Positive AVR is minus 150. Positive AVR is minus 150. So let's look and see what our axis is. All right. So if we say lead 3, perpendicular to lead 3 is AVR. Okay, everybody see AVR right there? But if you look closely, you see AVR is negative. AVR is not positive. It's not going up. It's going down. AVR is negative. So when you come, so you have your cheat sheet and you're looking at your cheat sheet, AVR is negative. So positive AVR is right up there. Because remember, this is the negative portion. Everything up here is negative. Positive AVR is minus 150. So negative AVR, you have to go in the opposite direction, the complementary angle. So negative AVR is plus 30. You just move in the opposite direction. This is the positive quadrant. So it's negative AVR is plus, okay. So negative AVR is plus 30. Okay. All right. So let's look at the axis. All right. So most isoelectric, lead 3, perpendicular lead 3, AVR, but AVR is negative, so that is why it's plus 30. If you were paying attention, you you clearly see that when you have your limb leads, lead 1 is perpendicular to AVF, and AVF is perpendicular to lead 1. Lead 3 is perpendicular to AVR. AVR is perpendicular to also to lead 3. And lead 2 is perpendicular to AVL, and AVL is perpendicular. So, so you don't have to go back. You can toss the cheat sheet if that's the only thing you are looking for, because, it goes like that. Okay? So, It, you move from 1 to AVL, lead 3 to AVR, and like that. So let me just, so that is why you use your cheat sheet for a little bit and then you toss it, because if you use it so many times, then it becomes straightforward. So these are the perpendicular leads. Okay, and they're always going to be perpendicular. So 1 perpendicular to AVF, 3 perpendicular to AVR, and 2 perpendicular to AVL. That's standard. It's not going to change. So again, as I say, the only thing you're going to need a cheat sheet is to tell you the different angles. But again, if you use it a million times, you'll remember the angles. You know that lead 1 subtends an angle of 0. Positive AVR subtends an angle of minus 150. Lead 2 subtends an angle of 60. AVL subtends an angle of minus 30. Lead 3 subtends an angle of positive 120. AVF subtends an angle of 90. So again, if you want to get into this and you use it, if you use a cheat sheet for a month, you toss it, because it's the same thing you're doing over and over and over. So, and it sticks, and you can impress people around you that you know to determine the axis. Again, the reason why we we do axis is because if the axis is abnormal, it can tell you a lot about the different disease that's going on. Okay. All right. So we already did that. Okay. And so, all right. So we have situations where you must have heard someone say, I'm getting skip beats or I feel my heart jump or something like that. That's because sometimes they're having premature beats. So you remember the heart, because of the electrical activity and the electrical uh, activity of the heart fires in a regular rhythmic fashion. The heart is normally regular, but sometimes it can fires early and you get a beat that comes earlier than normal. Remember, we have the atrium, which is on the top, and the ventricle, which is down the bottom. So you can have an early beat coming from the atrium or an early beat coming from the ventricle. If the early beat comes from the atrium, we call it a premature atrial contraction or PAC. Um, And if you look, the P wave is usually different from the regular P wave, but the QRS complex is identical. So this is a normal beat. Okay, so this is a normal beat. This is a normal beat. So these are normal, but this beat came early. This is a normal beat. This beat came early. If you look closer, the P wave is slightly different. Sometimes not so much, but and the QRS looks the same. The early beat, the QRS is the same. And then there's a pause. There's what we call a compensatory pause. Okay? So the thing about a PAC, the early beat looks almost identical to the regular beats. It just came early, that's all. And there's usually a P wave before the early beat, which is different from a premature beat that's in the ventricle. We call this a premature ventricular contraction, PVCs. Okay? So if you look on the rhythm strip at the bottom, you can see it's a beat, beat. You see they're equally spaced. It's regular, equally spaced, regular, equally spaced. Then this beat came. Okay, this beat came a bit early. If you look at the beat, it's wide, bizarre. The T wave is inverted. It doesn't look like the regular beats. And when it's wide and bizarre, it's what we call a PVCs, telling you that that premature beat is coming from the ventricle. Okay, so the QRS is usually wide. Okay, and the T wave, which comes after the QRS, is usually in the opposite direction to the normal T wave. Okay, so those are some of the things that will let you know that you're dealing with a PVC as opposed to a PAC. Um, and of course, when we say ventricular tachycardia, so remember we talk about sinus tachycardia, where the rapid beat comes from the sinus node. Then when we talk about a ventricular tachycardia, that means the rapid beat is coming from the ventricle. But the definition for a ventricular tachycardia is three or more PVCs that occurs in a row. That is the classic definition. Three or more PVCs that occurs in a row is ventricular tachycardia. And of course, you can have uh, supraventricular tachycardia. So the tachycardia comes from above, and supraventricular tachycardia, same thing as if you're going to say atrial tachycardia. That means it's above the ventricle, and then you have ventricular tachycardia, which occurs in the ventricle. We're gonna stop here, and the next session on Thursday we'll go into supraventricular tachycardia. But